So thank you everyone for joining today's Linux Foundation Decentralized Trust virtual meetup. Today we have a conversation about integrating Fabric Private Chaincode with Hyperledger CC Tools. We have a presenter, Osama Magdy, and we again invite any questions or comments you have throughout the event. Please feel free to ask questions or have comments if you'd like. And with that, Osama, why don't you take it away?
Thank you, David. Hello, everyone. I hope you enjoy and we can get a nice discussion together. So, for the past few months, I have been working on the Hyperledger mentorship project for integrating two different components, and they are Fabric Private Chaincode and CC Tools to increase the blockchain privacy in enterprise blockchain networks. This project was mentored by Marcus, Maria, and Samuel. So thanks you all for your effort with me, and we will start. Okay, so this talk will be covering, we will start by giving an overview about what is Hyperledger Fabric, what is Fabric Private Chaincode and CC Tools, why do we need the security benefits of one component and the simplification of the other, why we need the integration, and what are the challenges. And then we will conclude with a live demo explaining all the steps that are required by anyone to test the project we are making. Okay, so why this project matters? We will go back a little bit and start talking about what is Hyperledger Fabric, because some of you may not have the experience with the system we already. Fabric is a permissioned blockchain framework for enterprise solutions, which means that for other blockchain solutions, users are not authenticated. They are all able to view the execution of a blockchain logic or a chain code logic, which is not applicable for enterprise solution. So Hyperledger Fabric is a blockchain network that uses a membership service provider. Project matters. We will go back a little bit and start talking about what is Hyperledger Fabric. Sorry, someone was his mic was unmuted, so I muted his mic. You can hear me right, okay? David.
Yeah. Thanks for muting him. I was about to get to it, but thanks for doing that.
Yeah,
And I
okay.
can hear you.
Thank you. Okay. So like we said, Hyperledger Fabric is using a trusted membership service provider, which is the MSP. Okay, I can get a pointer so you see what I'm talking about. Okay, so the MSP is enabling Fabric to be suitable for enterprise application. And it also has a lot of other features, like it uses a pluggable architecture, which adds more freedom to uses or more different applications. And it supports some kind of data confidentiality. But what is the problem with Fabric Chaincode? There are two problems that our two components solving. First one is that it doesn't account for data sensitive applications. So for many of the enterprise solutions, they are requiring that arguments or the chain code logic itself to be executed in a confidential way that's not available to any malicious, even for peers. So Hyperledger Fabric requires some degree of trust assumptions on the peers or the contributors to the network itself. And this is where Fabric Private Chaincode comes into place. Okay, so as you can see from this diagram, this is a simple diagram explaining the architecture of FPC or Fabric Private Chaincode, which is another project by Hyperledger Fabric. This project is based on a true idea. One idea is that we execute the chain code itself in a trusted execution environment. For example, there is Intel SGX, which means that even the peers hosting the chain code execution themselves are not able to view the chain code. So this handles a trade-off that we always have been facing, that there is a trade-off between transparency of the blockchain, because if you remember, the whole cornerstone of blockchain network is the transparency, that users are able to verify the authenticity of a certain blockchain logic or a certain chain code logic by viewing that every peer on the network has the ability to verify the transaction itself. But on the other hand, for these users to verify the transaction, they need to be able to execute it and to get the argument itself. So how we mix both? This is the approach FPC is following, is by executing them in a trusted execution environment. On the hardware level, there is an encryption that reside inside what we call a chain code enclave that is not visible to even the host, the peer itself that's hosting the chain code execution. So with this setup, peers of the network are able to verify and execute the chain code itself without them knowing what is happening inside. Okay, so this increase the security level and increase the confidentiality of inputs, outputs, and everything is encrypted and not visible to the peers without proper permissions. What is the FPC transaction flow for this? We start with that the client application itself invokes the transaction with arguments, and the FPC client SDK encrypts these transaction arguments before sending them to the peer or the chain code enclave, and then FPC chain code enclave inside the Fabric peer here, this blue block. If you can see the screen. Okay, so this blue block is decrypting all the arguments before using them, and then start by executing the chain code itself, and then endorses it when the output is verified, and encrypt the response and send it back to the ordering service. So the ordering service is like a central place of execution where all peers are verifying that they have executed the chain code itself, and they are verifying the results, etc. There is some other feature by Fabric. I don't think really it's important for the context. Sorry for this. But it's always used that Fabric supports that all members of the network are not required to endorse the execution of the chain code, but we can like select a consortium of people to verify, and only their verification is required. And then after the criteria has been met by the ordering service for different peers, we can start to commit to the shared distributed ledger across all peers, and then the client receives the encrypted response, decrypted with his keys, and then is able to see the outputs. Okay, so this is the first component, which is FPC. The other component is CC Tools, and its whole mission is to simplify the development process of Fabric chain code, or what we call Fabric smart contracts. Because when CC Tools came into place, there were very complex development life cycle where you have to have a boilerplate code every time for put state and get state and communicating with the ledger. Basic operations or basic chain code or basic blockchain operations that are required by any chain code logic that is possible to be even there. So CC Tools creator thought of like, okay, we can make this simpler. We can have a pre-built code structure that we are enabling other users to start over it. So like you see from the code snippet here, is a complete transaction routine. There's a complete transaction structure definition where you have an example of a library, and then you have like, I want to have users able to do a create new library transaction, and then they are required only to process the arguments. I here put the arguments in a human-friendly, a very friendly and readable format that I am required only to give it a name, a string name for the library itself. And then the routine itself is just creating a new asset that's named library, and then put them in the stub itself, and it then get communicated to the ledger and put in place. So there are three important features of CC tools that we are needing to benefit from them. We have a pre-built chain code structure. We have automatic parameter handling. There is no need to check for every parameter of the code of the chain code itself, and the CRUD operation unsimplified for put or get or delete. Here, for example, if you see new asset and put new, etc. So still we didn't get to our project. So what we needed now is that we needed to benefit from both. We needed to enhance the security mechanism or security criteria or security features of a code developed by CC tools, and at the same time in making users able to develop simple and easy to develop secure code by FPC. So we need to collect both features at the same time. So this is a simple comparison between a standard chain code and an FPC chain code. And for data privacy, for execution security, for trust assumption, there is no trust assumption required in the FPC approach. Security is handled by the hardware itself by being executed in the trusted execution environment, and there is encryption for all arguments and input and output for the chain code level. Applications for this can be any privacy-sensitive use cases or data-sensitive use cases for financial transactions, for healthcare, for supply chain, and more importantly, for voting systems, like securing e-voting, where there is an undeniable need for permissioned blockchain networks because you need to be able to verify which one have voted for each candidate, etc. Okay, so what challenges in this integration we are facing? That CC tools and FPC were starting to come to life roughly at the same time, so there was no knowledge of each other, which means that CC tools was based on a standard Fabric network without taking into consideration the security requirements, the encryption and decryption required by FPC, and on the other hand, FPC is still using the older operations or older CRUD operations by by standard Fabric development cycle. Okay, and CC tools also for its client, it doesn't handle encryption or decryption for communication. So from this, we face that the integration must happen at two different levels. On the chain code level itself, CC Tools is able to simplify the development of the chain code, but it must adhere to the FPC privacy statements or FPC privacy features. And the development lifecycle was very complex with FPC because it was facing the standard Fabric code. So we needed to combine both features on this side. And for the client side level, we needed to enhance the clients of CC tools to be able to securely communicate with FPC and Fabric networks by doing encryption and decryption. There are some missing features from FPC that are out of scope of this integration because they were implemented in standard Fabric and CC tools was able to support them, but still in support or in future plans for FPC, so they are not a part of the integration project. That is transient data, events, and private data. Okay, so the integration architecture, what we used is that before, if you go to the transaction flow of CC tools, you can see that CC tools translates the code into standard Fabric chain code before interacting with the ledger. So like we said earlier, CC tools is a framework that's not messing with the code execution itself. It just simplifies everything from the developer perspective and then communicates with the ledger in the same standard Fabric way. And it performs in-memory operations by converting the pre-built code structure to a normal standard Fabric code or chain code logic. But on the other hand, FPC itself modifies the ledger interactions by putting encryption and decryption stages at the first, like we explained in the transaction flow before. And then before communicating back to the client, it do ordering and encryption and decryption before communicating with the ordering service and before communicating with the client to send the response back. So the right approach to do this was that the chain code itself must be wrapped with the FPC stub itself before CC tools processes it. And when the code starts execution or the chain code start execution, it goes in reverse. Okay, so CC tools stub will first translate its code to the FPC stub wrapper, which then performs the operations for communicating with the ledger and encryption and decryption, and then starts for dealing with the ledger in a normal Fabric standard way. So this is the approach we explained in here, that the user itself, when he starts to invoke, he will be faced with the demo chain code itself, which is written in CC Tools stub wrapper, and then gets translated to FPC stub before, and then a normal Fabric, and then communicated with the ledger, and vice versa. So this is the cycle of the integration architecture we performed, and we will communicate it in a demo now. So before we go to the demo, does anyone have questions? We can have like 5 minutes of questions before we go into the demo. Okay. Okay, so I already have had an example of the demo pre-executed to save us time. But I will go through the tutorial very quick. Okay, so this is one of the deliveries on our side that we are using a pre-edited or a pre-made tutorial provided by CC Tools, which is at CC Tools demo. This tutorial is providing a chain code written in CC Tools framework, and then we will start by converting it to be FPC friendly, or to use the security features or benefit from the security features on FPC side. This tutorial assumes that you have a rough experience with both CC Tools and FPC and Fabric. So if you don't, you need to finish the prerequisites section before starting with it. And it requires you to set up the FPC development environment before starting with the tutorial. Okay, so first off, we cloned the CC Tools demo project. I hope you can see my screen. Yeah, okay. Let me just zoom in a little bit. Okay, so this is a CC Tools, a chain code written in CC Tools with the CC Tools framework. And then we are searching how can we convert it to follow FPC. So a very first step is to see where the chain code as a service start, and we can see that in here at this block of code, if FPC enabled, if FPC flag is enabled, just need to the shim API of CC Tools is starting to get a new instance of the CC Tools demo tutorial, and then before injecting the CC Tools code with it, we wrap it inside a new private chain code instance. So this is fairly it. This is the wrapping architecture we were talking about, and we have implemented the shim API of FPC to be able to support this wrapping smoothly without any interaction from the user. So here in the tutorial, we are talking about what is the developer or the user are required to do to make their code converted from using CC tools only to use CC tools with FPC. So basically, you need just to wrap it with an FPC private chain code, new private chain code method, before sending it to the shim API of the CC Tools demo. Of course, you need to import the FPC library from here. Okay. And edit the Go mode to, we here edited the Go mode to be able to take it from our local FPC repo, because we are here testing in the FPC source code. So this replace is directing the Go application to look at the chain code itself, at the FPC itself components from our local environment. Okay, we also have a setup script that will do all of this for you without editing the Mingo. So anything, when you start the tutorial, you can find that there are no files here. All of these files are created by the setup script. You only need to edit the main code like we explained earlier, to wrap the chain code before sending it to the shim API of the CC Tools by FPC private chain code wrapper. Okay. We also had a script to be able to have all the commands that are required to be installed in place one at a time. And because I have made the tutorial before, I need to bring down the FPC network before. So that's what I will be doing now. I will now clean up every FPC code requirements or code components that I have in place. I will bring down the test network, and I will prune every containers and images that are already installed in the system. These are removing all or not required environment so we are able to start from scratch. Okay. After this, we will start by setting, we can start by creating an instance or the Docker image of the chain code itself. So after you finish development or editing of your chain code, like increase the number of transactions, like assigning rules or editing already present transaction. So this demo is not about CC tools, so we'll not go in depth about the code itself, but it's just important to say that the transactions are already created, are already developed, and we are using a pre-made example by CC Tools demo. So now I have my transactions already there, already coded. So I will start by using the make file. This make file was created also. It was explained in the tutorial that you need to refer to the ego config files and the ECC main files. Ego is used for signature during chain code execution and creating an enclave. So what I will be doing now is the making of the code itself. This will build the chain code instance and assign the enclave details to make sure that FPC to make sure that the chain code was not tampered after being created. This is also part of the security features that FPC follows, is that we have an enclave and a private key for every chain code. This MR enclave makes sure that the code has not been tampered with. It's a hash key of the chain code itself in a binary format. After making the chain code, you can check that the Docker image itself has been created. So if you run this command, we can see that it has been created 46 seconds ago. Okay. After this, we can start by setting up the Fabric network, the Fabric test network, which I have brought down by performing Docker compose down. So now we can start the network again. We should first make sure that we copied the whole required components. In the network exporter, it's not required. Basically, this setup script is cloning the required component of FPC. You can find it at, I'll tell you. It's present in deployment, test network, fabric samples. So all these files are copied or cloned by the setup script, and most of them are required for configuration files required by the peers for FPC. So again, to not be very deep about FPC, you can check this all in the tutorial because the tutorial is referring to them. Okay, so after the script, the setup script is completed, we can start up the network itself and create a channel. The name of the channel is important because this will be needed by the chain code to know where it should be deployed and installed. So we now start by creating. Sorry, did you stop the recording? Okay. Okay, so the recording just like for a minute, but we didn't do anything then. Just we're still creating the channel. It now finished creation, and it contained two peers, or org1 and org2. Names of the peers are case sensitive, so make sure that the name of the peers are put here in the environment variables as they are in the scripts. After that, we can start by preparing the network to install the FPC the FPC chain code. What we did in the first step is that we created the channel and assigned two peers to it, and now we are installing the FPC. Here if you see the MR enclave, this is for verification of the CC of the chain code itself, and this is the path of the CC Tools demo chain code. So we start by here and do install FPC. Install FPC is another bash script that's created, and it enables us to install the chain code without further complications. So now it's in the process of deploying the chain code itself to the channel and getting approvals from the two orgs here. If you can see, we are now approved by org1. By org1 and yet not approved by org2, and the approval of org2 is currently, yeah, it's already done now, and for organizations 2 everything is approved, and the chain code now is starting to be installed on every peer and its channel. Until this is done, I can show you the CC2's okay, so now everything is endorsed, and the chain code itself is installed, and we are now ready to start communicating with it and performing operations. Just to make sure that your system is up and running, here is the test network peers. We still didn't install the instance itself, and it will be by the ERCC script here. Okay. So now we start by configuration of the Docker Compose network for the enclaves of the peers itself, of the peers themselves. So here, all of these steps are mentioned also in the tutorial. So I am just copying and pasting the comments to save time, but they are all explained here. Okay. Okay, so the containers of the chain code application are up and running. Okay, so everything is is healthy, no errors. Now we will update the connection profiles for the FPC clients that we can create. These commands will create a CLI application and update the connection scripts of it, and use the update connection script to be able to communicate with the ledger and with the Fabric network itself. This will not take much time. Okay, so now we created a simple CLI that's able to communicate with the Fabric network itself. And by exporting all these environment variables, we will be able to initialize the enclave and start performing our operations with. So by just copying this, and also these values are present in the README tutorial. And then we initialize the enclave with the core PRD. It's initialized successfully. This is the first transaction. If this is also one of the features supported of CC Tools, that there are pre-built transactions. For example, the get schema, it's like a database schema. It will return to you the whole schema of the chain code itself. So for example, here we are aware that this is like a chain code for a system of a library. You can see from here that there are create new library transaction, get books by author. Also for asset types, we have a book and a person and library, and everyone has its own parameters. So if we executed this, we should be able to get a schema of a database of that chain code itself. So it's successful, and now we can be sure that now we have a CC Tools chain code that is using the FPC encryption and decryption capabilities. And even on my side as a peer, I cannot act as a malicious acting, and I cannot view the chain code itself without performing the standard operations. So if you can see, this is the same schema that I showed earlier. And also there are readers, asset type list, etc., library, etc. So this concludes our demo. I hope you were able to follow it smoothly. Also, we have a client application for CC API, but we don't have much time left. So I will just move to recap, and in the tutorial at the end you can see you can follow the next step of CC API tutorial. It's like a web server developed by CC Tools and is enabling us to deal with the code in a more web-friendly way from Swagger APIs. Okay.
Osama, can you show us again where exactly we find the tutorial, what you just presented?
Oh, okay. I will be sending all the link. They are in the presentation at the end for references. But at the end of the CC Tools demo tutorial, okay, you can find reference as a next step to the CC API tutorial. Just let me scroll down. Yeah, here it is. So at the end here, we are guiding you to a next step, and I invite you all to test it and tell us if anything is needing to be clarified.
Great, thanks.
Okay, thank you. So now back to the
Osama,
presentation. Yeah, sure.
one more question, because I'm not sure if you mentioned it or not. What programming language is used by CC Tools?
Oh yeah, I didn't. Yeah, okay. So all all coding and programming languages used in this project is written in Go. It's written in Golang, CC Tools demo, and FPC. FPC actually has a support for C++, but it was out of scope for the project. I only have been working on the Golang part of FPC, and everything is supporting only Golang project. Okay. So any other a recap about what we talked so far? We talked about that Hyperledger Fabric is important for enterprise solutions as it's permissioned blockchain network, and that Fabric Private Chaincode FPC is enhancing the security capabilities and security features of Fabric standard networks, and CC Tools is a promising project that enhances developers with the ability to develop blockchain networks or blockchain code more easily. And we explained the architecture of integration between FPC and CC Tools and how we are enabling this by wrapping the chain code with FPC before sending it to the CC Tools. Any questions else? We are open for questions.
Sama, I have another question. So you were saying that this trusted execution technology, which is leveraged by FPC in order to execute the chain code in an enclave or secure container, in order to provide extra confidentiality and in execution integrity. So I was wondering, I mean, if I want to start playing with FPC and CC Tools today, do I need hardware which supports Intel SGX? Is this required?
No, actually no, because as part of FPC development environment, it is virtualizing on a Docker-based dev environment that is using virtualization to mimic the approach by Intel SGX. You are not required to have all Fabric components installed locally. The whole demo we were using is that we were inside a Docker container developed by FPC. So if I just exited this, I am back to my normal machine, which is not supporting all the demo we are working. And also a note, because you asked, all the steps in the tutorial are required to run inside the dev environment. You should not run it outside unless you go for the option 2 here. So if you go to as a prerequisite section requires you to follow the tutorial by FPC with how you set up your development environment. So there are 2 options, like use a Docker-based development environment, which we have been using all this time. Option 2 is that you install all FPC component and set up the system to your local environment. This is, of course, more demanding to work. And if you faced anything, you can send us on the Discord. I will just show the communication channels after this slide. Does this answer your question?
Yes, cool. Thanks.
Thank you. Does anyone have any other question? Okay. Thank you all. In the slides, it will be, and we uploaded to the meetup link. Are the links for the Hyperledger Fabric documentation, FPC repository, CC Tools repository. This is the integration design document. I encourage you all to read it, how we are explaining the integration, how we need FPC to support other capabilities of Fabric and CC Tools, how it should be integrated with FPC. This is the integration tutorial demo that we have been executing for the past 10 minutes. And at the end is the CC API integration tutorial that I showed you and encourage you to test. If you want to contact us, this is my email. This is mails of my mentors. Marcos and Maria are part of the FPC project. Samuel is one of the main owners of the CC Tools project, and this is my email. You can also reach us on the Hyperledger Discord server. I put the link, and thank you.
Osama, I have one more question, a personal question.
Yeah, okay, sure.
Did you enjoy
yeah, sure.
feedback from you? What did you think about the project? Was it useful for you? That part. I think it's important because if new mentees want to, well, what was your experience?
Yeah, sure. I was just so focused on the technical, but I have enjoyed the mentorship a lot. I've learned a lot about different aspects of programming and software in general. I have enhanced my knowledge in Golang. I have been able to think in an organized manner. My mentors are also encouraging me to have a very detailed and explained approach before tackling any new solutions. It was fun. I enjoyed it. I learned more than ever about security and blockchain. I honestly invite everyone to contribute to the next mentorship project that will be, and also the integration project. Like we said earlier, it has some other future work. I hope you can contribute it and reach to us and enhance this project and enable everyone to test it in the future. And thanks to Marcos, Maria, and okay, so we have a question. What are the biggest learning in this project in terms of security? Learning about trusted execution environments. I have been debugging a lot I was able to check the enclave and using cryptography keys to check the authenticity of the chain code that is not tampered with. I always faced issues with encryption and decryption on the client level, and also integrating between two different components that one of them is not even handling security. So this was somehow my learning objectives that I got from contributing to the project about security. It's more about blockchain and asymmetric encryption and symmetric encryption, because there are different set of keys that have been used by FPC to make sure that everything is executed is confidential and not tampered with, because this cycle of encryption and decryption was very hard to understand at the beginning, but with the help of my mentors, I was able to learn from it. Okay. I hope this answers your question, Eno. Thank you. Okay, so if we don't have any other questions, I think that's it for us. I can stop the screen.
Great.
And thank you.
Yeah, thanks for presenting, and I'll send links around to everybody who signed up after this. And as Osama said, if you want to stay involved in the community and ask more questions and just connect with other community members, please join us on our Discord server.
Okay, thank you.
Thanks, everyone.
Great, thank you. Bye.
Bye.
Bye.